Dan and I have known each other since 1973 or 4. Dan and I and Keller McDonald, our retired school superintendent, worked at a Boy Scout camp for a couple of years up in the Sierras. And so, as life is, you go your separate ways, and Dan went into the world of biology and biotechnology starting in early in his career with Genentech. I think he had an employee number of 212 or something like that, and was with Genentech for a number of years, and ended his career with a company called BioMarin in Marin County. And today is, how many knew that there was such thing as a World Rare Disease Day? You knew?
I knew, because I had one.
Okay. Well, here's what you have to know. Well, not for the disease, but anyway, just catching up last night at dinner. What they're doing is fascinating. What's going on is fascinating. I'm reminded of an old joke we used to see in this book my parents had around the house, and it was a fraternity, and one of the guys said to one of the other guys, you know, you gave me a nickname, and these nicknames kind of tend to stick with you through life. And my name's Bill, Big Bill. I'm going to be a doctor, and I don't want to be known as Big Bill, the doctor. So, with that, I'd like to bring up Speedo Mayor.
Mr. Speaker, how do you do? Is there anything that we can do for you? Thanks for coming here today. We are with you all the way. How do you do, honored Speaker? How do you do?
He does not like microphones, but he is loud. So it's here if you want.
No, you should use it.
Oh, you should use it.
Use it.
Use it. Yeah.
Use it.
Give me a chance first.
No.
Oh, give him a chance.
I like to talk with my hands and move around and get engaged. So, but if you really need it, I'll do it. Thank you for the invite, kind sir.
My pleasure.
Terry and I go way back, as he alluded to. Another thing that is so special about our past and our current, in fact, the invite allowed me to catch up with Terry and Sue, so that's been very, very nice. We're both Eagle Scouts, and we met at a summer camp high in the Sierras, and the relationship carried on for almost 40 years, as you know. So.
And your father's Rotarian, was a Rotarian?
He was, yes, he was. Today's National Rare Disease Day and International Rare Disease Day. One fact about rare diseases, or orphan diseases, and I'll explain that, is if you were to take cancer, diabetes, cardiovascular issues, AIDS, and any major large disease you're well aware of, they are dwarfed by the number of patients in the world who have a rare disease as defined by just a few thousand in some cases people in the world, or up to 200,000 people with the disease. So that number dwarfs all the other large diseases in terms of prevalence that you've heard of. So that's pretty amazing. So there's all kinds of stuff going on. In fact, I'm going to BioMarin later this afternoon to be part of a big celebration there, and some of our patients will be there, and so on and so forth. I'm going to talk to you a little bit about an example of one class of rare diseases. I'm going to talk a little bit of biology, so I apologize if it seems too simplistic to those who are biologists or technically trained in the room. But I want to give you an idea of what a rare disease might look like. By no means am I going to talk about more than one class of disease, but there are 6,000 plus rare diseases identified in the world and counting. Most of those have a genetic basis, like most disease does. And another important piece to keep in mind is rare diseases, and even ultra-rare diseases, which is what I've worked on for my last 13 years at BioMarin, are really diseases that only have, in some cases, just a couple thousand patients or people in the world with that disease. And I'm going to talk about an example for you. There is, you remember your high school biology class, the cell, right? In the cell is the nucleus. You can take the city of Sebastopol, and the nucleus might be City Hall. City Hall has all the records. In the case of a nucleus in the cell, the DNA, which tracks those records and assigns responsibility and ownership. Well, a nucleus has the DNA that does that. There's something in a cell called endoplasmic reticulum. Forget about the name, but it's really a series of highways that transport products. In the cell, there's something called a vacuole. A vacuole might be analogous to a tanker truck that brings gasoline or fuel back and forth to gas stations, or from the factory or the power plant. A power plant here or local might also in the cell be called a Golgi apparatus. So the cell has all this stuff. Every single cell in our body has all this stuff. But there's one important part to a city that's usually in the outskirts. What might that be? A dump. And in the dump, where you go and take stuff to the dump, there's usually piles of stuff. Metal goes over there, landscaping, yard waste goes over there, plastics and other stuff goes over in that pile. Well, the dump in the cell is called a lysosome. There's literally thousands of lysosomes in every one of our cells. In every one of those lysosomes, or dumps, there's different piles. Well, there's different enzymes. There's over 60 enzymes. An enzyme is nothing but a protein that's configured a certain way, and it breaks down other proteins. But in every lysosome, in every dump in our cell, is 60 plus of these enzymes. Now, what happens in the cell when the Golgi apparatus, the factory, the power plant, it kicks out proteins that we use, the cell uses, to live. And sometimes the ribosomes, or the little robots on assembly lines, mess up what they're producing. So a protein will get sort of screwed up. And what happens is the cell recognizes it, and it sends the messed up protein to the lysosome, the dump. And in the dump, one of those 60 plus enzymes recognizes the errant protein, and it says, okay, I need to chew that up and reuse the parts. Because dumps often take all of their plastics and sell them to plastics manufacturers, and they remake stuff. Well, that's what the cell does. Everybody following me so far? Yep. Okay. So, if you have a genetic mutation that screws up one of those 60 plus enzymes in the dump, if something goes there to the dump because it needs to be recycled, and if the enzyme is screwed up and can't recycle it, what do you think happens? It builds up. It builds up. There's, like in a dump, a big pile of stuff that gets bigger and bigger and bigger because the dump doesn't know what to do with it. So that's called a lysosomal storage disease. Okay? And what happens, unfortunately, to children born with these diseases is the stuff in their cells accumulates in the dump, in the lysosome. And instead of a lysosome being this big, it's as big as this room, comparatively speaking, full of junk that can't be recycled. So in these kids, they're very sick. The disease starts in the womb. And if it's a severe form of a disease, an LSD, a lysosomal storage disease, they don't live into their early teens. If it's less severe, they might be young adults before they expire. And what happens? Remember, every cell in the body has many lysosomes. So in every cell in the body, the cornea, the heart valves, the joints, the muscles, all the cartilage, all the connective tissue gets clogged with all the stuff that can't be recycled. Okay? So that's the disease. Lysosomal storage disorder, or another class within a subclass of that disease is called MPS disease. I won't even bother to tell you what that stands for. So to make a long story short, BioMarin was founded 20 years ago, focusing on these sorts of diseases. And remember I told you about that enzyme in the lysosome that's mutated, that's messed up? What BioMarin does is use genetic engineering to make that enzyme and target it and give it back to the person, and it goes right into the cell and into the lysosome, restores the functionality, and that big pile of stuff that built up over time now gets recycled and diminished. That's the essence of the biology behind lysosomal storage diseases. So what about BioMarin? Actually, I retired 2 years ago. I'm still associated with the company, and I'm the company historian. And what they've done is take this whole concept of making stuff that's identical to the human stuff, but correct stuff, and assigning a little tag to it so that it gets right to the dump in the cell, the lysosome. And that's, believe me, it's a lot easier said than done. But BioMarin in that county just south of here, the headquarters is in San Rafael, on Mondadaro Street, those big buildings there. It's a $15 billion company.
Wow.
It's the largest employer in Marin County, and it's one of the largest well-known biotech companies that serve orphan diseases. An orphan disease is classified as a disease with 200,000 people or less. An ultra-orphan company like BioMarin treats diseases where there are, in many cases, just a few thousand people in the world with these diseases. In the world. So the business model is quite unique, you would imagine. How do you become a $15 billion company when you're treating a disease where there's 2,000 people in the world, and 2/3 of those people are outside the United States, which is also characteristic of these rare diseases. Can anybody imagine why more rare disease, ultra-orphan disease patients are outside the U.S.? More people, but I'm talking about the incidence, the number, per 100,000 people. Well, it's because of genetic inbreeding. Third world countries, just by the nature of the poverty and the location and the geography, do more breeding with more close family members. That leads to these genetic mutations that leads to these diseases.
Does that mean that immigration is good?
You know what? I'm just going to move right on here.
That was good. That was good.
So that's really the story. Now, what I want to do is, and Mr. President, you'll have something like, how much more time? 10 minutes? 15? 10? These are diseases then that are very important to treat. Philosophically and culturally within the company, there's a strong belief that no disease is too rare to treat. But it's been very, very hard over the 20 years. The company started in Nevada, out in Belmarin Keys, and its original factory, still there today, but much bigger and much more expensive, was the Birkenstock shoe factory building. It's now BioMarin's manufacturing plant where it makes several products that treat these very diseases that I'm talking about. If you're driving by up the freeway and you look to your right, you'll see the largest building over there. That's formerly the Bourbon Stock Factory. There you go.
That was the original.
So that's where one of our factories is. The other one's in County Cork, Ireland. And BioMarin technically is an Irish company, which made me happy since I was born on St. Patrick's Day. And I'm an Irish citizen in addition to a U.S. citizen. Terry and I were just talking about that last night. So that's the sort of the whole story. Now let me just spend a few minutes talking about other things related to biotechnology. But now I hope you have sort of an image in your mind of an analogy of a city to a cell and what can go wrong. So whenever you might hear of BioMarin in the future, you can say you heard the whole story about the dump and everything here. Yes, sir?
Are these related at all to autoimmune diseases?
No, they're not. Yeah. All diseases have a form of inflammation, which is a big result of autoimmune diseases, but it's a different set of diseases. Yeah. The future of biotechnology actually is focused on immuno-oncology, which is related to autoimmune disease. I mean, my mother passed away of lupus, which is one of the largest and most insidious autoimmune diseases you can have. What the future brings is going to be very, very interesting and challenging. There's technologies today that when I started at Genentech 35 years ago were unimaginable, really. There's gene therapy that's been around a long time, but only in the last few years is gene therapy working. Now, what is gene therapy? It's a lot like what I just described to you, but slightly different. It's not replacing the enzyme or the stuff that's broken in a lysosome. It's actually taking DNA and using a virus to deliver it to the nucleus or City Hall. So if City Hall has a water pipe that broke and ruined the DNA records in store in the clerk's office, well, what happens is the Golgi apparatus or the delivery system delivers strength or power to City Hall by taking a virus, incorporating human DNA, the correct human DNA, and sending it to the clerk's office, fixing the broken water pipe. So their records now are sustained and go forward. So that's gene therapy. Now, there's an approval of a product in the U.S. Recently by Spark Therapeutics. And one of the downsides or the difficulties of the future of healthcare, not just in my opinion, but in everybody in the industry, is really the cost of fixing a disease. So Spark Therapeutics in Cambridge, Massachusetts, just got approval from the FDA to fix an ultra-rare eye disease where babies born with the disease go blind in just a few years. Unstoppable. The eye is a compartment that's very protected, but they actually do gene therapy and inject a virus into the eye that gets absorbed by the retina, fixes what's broken, and prevents blindness. Prevents it with one shot. Only about 300 children are born every year with this disease in the U.S. Spark announced the price they're going to charge for that one shot into the eye to prevent blindness. In essence, answering the question on what they think sight is worth. You're all thinking, well, what is that number?
Zero.
$850,000. And Aetna and Blue Cross are going, whoa, 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 whoa. Almost $1 million for a child to keep their eyesight. That's going to be a dilemma going forward, because there's going to be more and more therapies coming out with gene therapy that cure even more significant diseases. BioMarin's one of them. There's a disease called hemophilia. You've probably heard of it. There's A and B. It's one of the most prevalent genetic diseases in the world. And BioMarin has basically a gene therapy, in this case not to the eye, but to the liver, which is the problem area for hemophilia. The blood factors aren't manufactured properly in the liver. And they're in phase 3 trials. And so far it looks magnificent. Hemophilia is a devastating disease. I won't get into the natural history of the disease, but basically in earlier trials, one shot, poof, the disease goes away. And you're going to be hearing more and more about gene therapy, because now the delivery vector, the virus technology, actually works. And companies now are scrambling to use this technology to not just treat diseases, but to eradicate them.
Wow.
That's happening now. Sir?
You talked about the business model. The patients that have these rare diseases aren't paying for BioMarin's costs. The insurance companies aren't yet paying, because they're not, many of them are not approved on their plans. Is it investors who's paying for BioMarin's costs at this point?
Right. Yeah. I mean, the cost of developing these therapies are very expensive, and companies need to charge to recoup the investment. There's lots of arguments for and against that model. BioMarin, for instance, on the lysosomal storage disease that I described to you, the average cost charged to the patient's care provider, and it's different by country. In many cases it's countries, not insurance companies. It's $500,000 a year. That is what we charge.
Per person?
Per person, per child. Correct. Yes?
First, I want to comment, thank you for an alternative definition of LSD. But my question is, once you cure this genetic disease, then that person cannot pass that defective gene down to their descendants?
Great question. And I have the question is once we treat the patient, let's say the person the child who keeps their sight, can they pass that disease down to their progeny? The answer is yes. But there's another technology even newer than gene therapy called CRISPR-Cas9. You might have just heard the term CRISPR. It's a very, very interesting wave of technology being developed. There are billions of dollars invested in CRISPR-Cas9 related gene editing companies. Okay? CRISPR is nothing but a pair of scissors designed to specifically cut out a bad part of the gene and splice it so you don't have the bad gene. And it does it in every cell in your body, including your germ cells or your reproductive cells.
Nice.
You might imagine good stuff that can happen from that and bad stuff. The use of CRISPR technology in human cells has a moratorium on it for the last 4 years Just like in the early days of recombinant DNA when I first started. But guess who's doing CRISPR human cell experimentation? China and North Korea. Already published. But if used correctly, this gene editing technology specific to cutting out the bad stuff in the City Hall records can be very, very powerful. But it's also to be told more of a story as we go forward. Sir?
So you've got this enzyme that you fixed, right? There are billions of cells in the body. How do you have to replicate that new enzyme? How do you're changing one cell, how do all the other cells get changed?
Great question. Patients have to go in every week for 4 hours for a weekly infusion so that their whole body gets marinated in that enzyme. And that enzyme has a little flag on it that says, "Take me to the lysosome." It's called mannose-6-phosphate. And that little flag takes it to all the cells, and just enough gets to the lysosome. And the lysosome, because it sees that little tag, says, "Come on in." But it has to be done weekly.
For how long?
For 4 hours. And it's hard.
No, for what duration?
For life. Sir, I'll be right over there.
But are you involved with immunotherapy for cancer treatment?
Yes, I am. Immuno-oncology is sort of the class of new technology going forward. It's going to be amazing. CAR T therapies, et cetera, et cetera, et cetera. And gene therapy will be applied as well. Yes. Sir?
You said that the delivery system for this was a virus.
That's for gene therapy.
So when I hear virus, I think, oh, that's something you get sick from. But is this a type of virus that doesn't hurt the system when it goes inside?
It's been genetically engineered to not do harm.
But it's a vehicle or a delivery.
It's just a tanker truck taking a load of enzyme or DNA to wherever it needs to do its work. But in the early days, 30 years ago, the virus wasn't deactivated properly and it wasn't figured out how to deliver it and how often. And actually patients were killed in clinical studies. And that's what set gene therapy back for decades. But that's all worked out now. Yeah. No,
Yeah, thank you for coming.
pleasure.
For you, we have a raffle draw. So, pull out a
Will do.
This is sort of like all the research. You never know what you're going to get, you know? Yeah, think about it. $800,000 for a single shot or a cure sounds like a lot of money, but a guy making $50,000 a year in 16 years of zero income and having society take care of him, if he's fully cured immediately, you know, it's a reasonable payback. And the winning ticket is 8396.
Rich Henry.
It's been a long time.
Okay, and you get to
Excellent presentation.
Really?
looking for the ace of spades here,
Thank
and
you.
the lovely gift from John Palusis this morning. Beautiful, huh?
From John.
Okay.
8 of hearts.
8 of hearts. Oh, so close.
Not yet. Yeah. Here we go.
Joe!
Oh, now remember back in the days when there were girls' schools and boys' schools and college? Well, there was a contest at a girls' school to write the best short story that included religion, sex, and mystery. And the winning title was, "Oh God, I'm pregnant. I wonder who did it."
Joe, take us out with a song.
Trails to you, Batman.